So here I have developed one application. Using this application, we are going to classify the quality of the tomato. So how to classify the tomato quality, that we are going to use the transfer learning. So this transfer learning is in deep learning algorithms. So here, this deep learning algorithm, we are going to extract the features from the tomatoes, and the machine learning algorithms which we are going to train after this extraction to predict or to classify the quality of the tomato. Now here you can see here in this abstract. So in the existing system, we have used the inspection v3 algorithm to extract the features with some accuracy, less accuracy. So what we are going to do, we are going to add one more the proposed the deep learning model, that is efficient at B0 for the feature extraction. So due to the high accuracy and the lightweight architecture. Okay, so after the extracted the feature extracted from the pre-processed tomato images are passed through the traditional classifiers, which are the existing, like the machine learning algorithms. The what we are going to use, the SVM, support vector machine, random forest, and the XGBoost. So these are the machine learning algorithms which we are going to train using these extracted features to classify this quality of the tomato. And you can see that there are the keywords. What are the keywords here? Tomato quality classifications. There are the keywords. The main aim of this application to develop an efficient and accurate tomato quality classification system using the transfer learning based on the feature extractions. The feature extraction uh, based feature extraction, the efficient B0, and the traditional machine learning. This is an objective. The objective is to extract the features from the tomato image using the efficient net B0, and they classify them into categorical like damaged pot, damaged tomato, or old, and rip and unrip tomatoes using the classifiers such as SVM, random forest, and XGBoost. So there's a, problem statement, and you can see the existing system also. In the existing systems, we used inspection v3 is a computationally heavy and the less suitable for the real-time or the embedded system, lack of the visual interpretation of the internal CNN features operations. These are some disadvantages. And coming to the advantages, uses the efficient net B3, which provides the better accuracy and the fewer parameters, improve the performance in the multi-class classification of the tomato quality. Multi-class classification, nothing but we are going to classify the four types of the classes of the tomato. Okay, so this application, whatever we are seeing this application, this content, I have used the Flask. The Flask is nothing but it is a framework. So using this framework, we can able to develop the web applications. So yeah, I've used the Flask to develop such application to classify the quality of the tomato. So now I'll run that application. I'll show you that application and how we're going to classify that tomato. I'll explain you now. You can see here. So I'm going to open the command prompt here, or else in PyCharm. So going to the terminal. Already it is running. Yes, exited from that. CLS, clear the screen. Next, I'm just writing Python app.py. Now you can see here we got one URL. So based on this URL, we can able to execute our project. So this URL is nothing but why they are generating the URL, because it is a web application. So we must run this URL in the web. Okay. So I'm just copying this. Going to open the browser now. Straight away. Now enter. Okay. So this is an application where this is the front end. So you can see here I have created two modules. First one is the admin module, second one is nothing but a user module. Who will check that quality? You have obviously user will check that quality. So that is the reason I'm just using it. uh, One name is check the tomato quality. I'll show you later. I'm going to the admin side now. In admin, you can see here admin start now. Okay, so I enter into admin home. So in this admin home, Just click here, upload the data set. So I'll show you the data set also here. You can see train, damaged. These are the damaged images and the old images. So this is the data set. So I'm directly taking that path. The next to feature extraction. So I already extracted features, but it will take time. So that is the reason I already dump into file. You can say pickle file. Okay, no features and the labels I already done. Okay, means it will take some time to extract the features we have because we have 6,500 images. Okay, so then next also generated ML models. So our models already generated. If you want me to generate the models or if you want to show you, I'll just delete it. Now if I click here, generate models. Now going to the browser, you can see here. Sorry, PyCharm. You can see here command prompt training that SVM. You can see the classification report also here. Yes, classification report. Now the accuracy will be 98% accuracy. You can see the classification report. Now damaged for the damaged report, it is 99%. The precision, the recall, and the score, and the support, and what it is training. The random forest is providing almost 95% accuracy now training the XGBoost algorithm. So it will also give that better accuracy only, but we'll consider the 90% will be the higher accuracy. So when I'm training, so the models I'm going to save as a pickle files because so I don't want to train every time because the training it will take some time. So mainly these projects are going to use in the academic level of the student. So they need to show to the present, nothing but present to the externals or the guides. So it will take time. Now you can see 97% accuracy. So better accuracy is 98% only. So this is the 98% accuracy. Now you can see all the three models are saved as the pickle files. Now go here. After that, generating the model generated successfully. Now, if you want to see the classification report, you can see the classification report of each and every labels. You can see here SVM classification report, almost nearly 90 above accuracy. We are getting the score and the exhibit reports. Okay. Now you can see the accuracy also. Accuracy 97.77, almost nearly 98 accuracy we got to the SVM and 96 to the exhibit, 94 to the random forest. So this is an admin side. I have created some admin model and that assigning some admin operations to the that point particularly and going to the user side check that directly I have given the check option. So just click on upload that image. You can see here where it is. Yes, going to the tomato quality and test images. So now I'm just uploading some image here. Now upload. You can see here upload image. This is an uploaded image. Now classify. Click on the classify quality. Now it is analyzing. Wait for a few minutes. Now you can see this is the damaged fruit. What it is classified? This is classified as the damaged fruit. Also, let's go to another. Now this is what this. This is one of the fruit I'm uploading. Okay. So the quality classified as a old. This is an old tomato. So this is the quality of the tomatoes using that SVM algorithm. But extracting the features based on the efficient net B0, that is a transfer learning model, nothing but a deep learning. This also comes under the deep learning. And coming to the machine learning, we are using the SVM, the random forest, and the XGBoost, comparing the also. Okay. So this is the about the tomato quality classifications. So if you need any like projects, or any development, we'll provide that development also. Please contact with us.